in order for us to do these questions that are of this form, then we are supposed to remember cos theta is equal to this. We're supposed to remember sin theta is equal to this. And we are supposed to remember d theta is equal to this, because these are the values that we will be using. So we will be replacing each and every time we have these values, we will be replacing t is equal to tan theta over 2 and replacing the values of the sine theta, cos theta, and d theta as well, so that you can be able to evaluate. Now, let's take up an example. Let's say we are told to find the integral of d theta over sine theta. Now, replacing, I have sine theta d theta. Integral of 1 over, what is the value of sine theta in terms of t? We say that sine theta is equal to 2t over 1 plus t squared. And then d theta. So multiplying by d theta, we say that our d theta is 2 dt, all this divided by 1 plus t squared. So simplifying that, then carrying out the integral, we will have 1 divided by the whole of this is the same as multiply by the reciprocal. So I have the integral of 1 plus t squared, all this divided by 2t, multiplied with 2 dt, all this divided by 1 plus t squared. Okay, this and this are similar, so they can cancel out, so that I remain with integral of 2 over 2t dt. 2 will go, so that I have integral of 1 over t dt. And what's the integral of 1 over t? It is ln t. But remember, we were using the substitution, t is equal to tan theta over t over 2. So our final answer is ln. Instead of t, we will have tan theta over 2. That's how we go about it. So we transform the whole question into t, and the final answer, we write it back in terms of theta. Let's take up another example. Let's say you're given a question like this. So integral of d theta over cos theta. Now this is 1 over cos theta multiplied by d theta. Using the substitution, t is equal to tan theta over 2, we will have 1 over cos theta in terms of t is the same as 1 minus t squared, all this divided by 1 plus t squared. And d theta is the same as 2 dt, all this divided by 1 plus t squared. So what do we have here? 1 divided by this is the same as multiply by the reciprocal. So I'll have 1 plus t squared over 1 minus t squared multiplied with 2 dt, all this divided by 1 plus t squared, the integral of this. This right here is the same as this, so I can cancel that out, so that I have integral of, I can write 2 outside, or I can just have 2 in here, no worries. So that I have that as integral of 2 over 1 minus t squared dt. Okay, and then integrating that, what do we get? So evaluating the integral of this. So I can write this as in order for me to evaluate this integral, I will choose to write this in terms of, let's see, I can be able to write this in its linear form. So I can have it as 2 over 1 minus t squared is a difference of 2 squares. So this is the same as 1 minus t, 1 plus t dt. Then I can be able to write this into partial, so that I can have them separately. So writing this into its partial, 2 over 1 minus t, 1 plus t, to partial, I will have this as a over 1 minus t plus b over 1 plus t. I open it up as a linear factor. Okay, then putting it under the same LCM, so I will have the LCM is 1 minus t, 1 plus t. Then I have a here into this goes here, 1 plus t, plus b into this goes here, 1 minus t. This is equal to 2 over 1 minus t, 1 plus t. Okay, so in order for us to get the values of A and B, we choose random values of T, 2 random values because we have 2 unknowns. So when T is equal to, let's say 1, on the numerator, we will have 2 is equal to, here we have 2A. When T is 1, this side will give us a 0. So A is basically equal to 1. Then choose another value of T. When T is equal to, let's say, -1, on the numerator, we will have 2 is equal to, T is -1, so this will give us 0. T is -1, so 1 minus minus, that will give us 2B. So B is also equal to 1. So coming to rewrite this, A over 1 minus T, so that will be 1 over 1 minus T plus 1 over 1 plus T. This is what we need to integrate with respect to T. And integrating that, what do we get? So the integral of 1 over 1 minus T is the same as ln 1 minus T, plus the integral of 1 over 1 plus T is the same as ln 1 plus T. Okay, and since we don't have the ranges, we can write that as plus C. Now remember, we need to transform this back into theta, so plus C. The substitution was T is equal to tan theta over 2. So where there's T, we put tan theta over 2, such that our final answer will be equal to ln 1 minus, instead of T, we will have tan theta over 2 plus ln 1 minus tan theta over 2, tan theta over 2 plus C. And this gives us our answer. So basically, whenever you're given a question, you just substitute the values and then replace back. Example number 3. Let's say you have integral of d theta over 1 plus cos theta. So I want us to substitute for d theta and cos theta in terms of T. Now, since T is equal to tan theta, what is our d theta? Now, our d theta, from whatever we already wrote, our d theta is equal to 2 dt. So I'll just substitute it here, 2 dt over 1 plus t squared. We are dividing by this, so which is the same as divide by 1 plus, what is cos theta? Our cos theta is 1 minus t squared over 1 plus t squared. Okay, fine. Let's put this under the same LCM so that we can now write it properly. So we have this as integral of 2 dt over 1 plus t squared divided by, so putting this under same LCM, the LCM is 1 plus t squared over 1. So 1 goes here, we have 1 plus t squared, and then 1 plus t goes here 1, so I have plus 1 minus t squared. Okay, so this basically simplifies to integral of 2 dt over 1 plus t squared divided by is the same as multiply by the reciprocal. So the reciprocal, we have 1 plus t squared up here, and down here, this is, and this will just give us a 0. Then we have 2 over here. So this 2 will cancel with this, and this will cancel with this. So basically what we are remaining with is the integral of dt, or integral of 1 dt. And if you integrate 1 dt, you just get t plus c. But what is our t? Our t is tan theta over 2 plus c, and this is the answer. Okay, guys, so that's how you go about tan theta over 2 substitutions.